The speed of light is not just fast, it is a fundamental limit built into reality. The speed of light is often introduced as a very large number, something impressive but abstract, measured in kilometers per second and memorized for exams. However, treating it as merely very fast misses its true meaning. The speed of light is not simply about how quickly light travels through space. It is a fundamental property of reality itself. It defines how the universe is structured, how events are connected, and how cause and effect operate. This is why it is not just a speed, but a limit that cannot be broken without destroying the logic of the universe. To understand this, we must first let go of the everyday idea that speed is relative in the way we experience it. In daily life, motion is flexible. A car can move faster than a bicycle, and an airplane can move faster than a car. There is no obvious upper boundary. It feels natural to assume that if technology keeps improving, we should eventually be able to go arbitrarily fast. But the universe does not work this way. At a deep level, nature has placed a strict ceiling on how fast information, energy, and cause can travel. That ceiling is the speed of light. What makes this limit so profound is that it is the same for everyone. No matter how fast you are moving, if you measure the speed of light, you will always get the same value. This is deeply counterintuitive. Normally, if you chase something, it appears slower relative to you. But light does not behave this way. Even if you were traveling at 99% of the speed of light and measured a beam of light moving away from you, it would still move at full light speed. This single fact forces the universe to rearrange its basic rules. To protect this constant speed, space and time themselves must become flexible. When something moves faster, time slows down for it compared to a stationary observer. Lengths in the direction of motion shrink. These effects are not errors of perception or measurement. They are real physical changes. The universe sacrifices absolute time and absolute space to preserve the speed of light. This shows that light speed is not just a property inside space and time. It shapes space and time. Another way to see why light speed is fundamental is through the concept of causality. Causality means that causes come before effects. For this order to be meaningful, there must be a maximum speed at which information can travel. If signals could move infinitely fast, events could influence each other instantaneously across the universe. This would erase the concept of before and after for distant events. The speed of light acts as the ultimate speed of causation, ensuring that the universe has a consistent timeline and that reality does not contradict itself. As objects approach the speed of light, their behavior changes dramatically. Energy and mass are no longer separate ideas. They become two sides of the same thing. Increasing speed adds energy, and that energy increases inertia, making further acceleration harder. Near light speed, even a tiny increase in speed requires an enormous amount of energy. At the speed of light, the required energy becomes infinite. This is not a technological problem that better engines could solve. It is a mathematical and physical impossibility. The universe simply does not allow infinite energy to exist in a finite object. This is why saying nothing can go faster than light is not a rule imposed from outside, like a law written by an authority. It is an internal consistency condition of reality. If something could exceed light speed, it would imply signals traveling backward in time from certain perspectives. This would allow effects to happen before their causes, creating paradoxes that cannot be resolved. The light speed limit prevents these contradictions from ever arising. Light speed also defines the structure of the universe in terms of what can be known and observed. There are regions of space so far away that their light has not had time to reach us since the beginning of the universe. These regions exist, but they are causally disconnected from us for now. This creates a natural horizon, not because space ends, but because information is limited by light speed. In this sense, the observable universe is shaped directly by this fundamental limit. Perhaps the most mind-expanding realization is that light speed is not only about light. It is the maximum speed of all massless influences and the ultimate conversion factor between space and time. When physicists write equations, the speed of light often appears not as a velocity, but as a bridge linking different aspects of reality. It converts seconds into meters and energy into mass. This shows that it is woven into the deepest equations describing existence. Calling the speed of light fast is like calling gravity strong. It is technically true, but conceptually shallow. The speed of light is the universe's way of maintaining coherence. It is the limit that keeps time ordered, space meaningful, and causality intact. Without it, the universe would not merely behave differently. It would fail to function as a logical, consistent reality. That is why the speed of light is not just a speed. It is the backbone of how existence holds together. Time and space change to protect this cosmic speed limit. When we first hear that time slows down and space shrinks, it sounds like science fiction or a clever mathematical trick. In everyday life, time feels steady and universal, and space feels fixed and solid. A second passes the same way for everyone, and a meter is always a meter. But the universe does not agree with this intuition. To preserve the cosmic speed limit, the speed of light nature forces time and space themselves to become flexible. This idea is one of the most radical discoveries in human thought, because it means that reality is not built on absolute time and absolute space, but on a deeper structure where both adapt to motion. The need for this flexibility begins with the strange behavior of light. No matter how fast an observer is moving, the measured speed of light remains exactly the same. This simple statement has enormous consequences. If time and space were rigid and unchanging, different observers would measure different light speeds, just as they do with ordinary objects. Since this does not happen, something more fundamental must give way. The universe chooses to protect the speed of light at all costs, even if that means rewriting the rules of time and space. Time dilation is one of the first results of this protection mechanism. As an object moves faster through space, it moves more slowly through time. A clock carried by a fast, moving object ticks more slowly compared to a clock at rest. This is not a flaw in the clock or a psychological illusion. Atomic clocks on fast airplanes, satellites, and spacecraft have confirmed this effect repeatedly. Time itself flows at different rates depending on motion. The faster you move, the slower your personal time passes relative to others. At the same time, space undergoes its own transformation. Length contraction occurs along the direction of motion. An object moving at high speed becomes shorter when measured by a stationary observer. From the object's own perspective, nothing seems unusual. It still appears normal in size. This mutual consistency is crucial. Each observer experiences their own time and space as ordinary, yet the measurements differ in a precise way that keeps the speed of light constant for everyone. These two effects, time dilation and length contraction, are not separate tricks. They work together as a unified system. By slowing time and shrinking space in just the right proportions, the universe ensures that light always travels the same distance in the same amount of time for all observers. This balance is exact and unavoidable. It is not chosen by preference, but demanded by the structure of reality. As speeds approach that of light, these effects become extreme. Time slows dramatically, and lengths compress significantly. At the speed of light itself, time would completely stop for the traveler, and space in the direction of motion would collapse to zero length. This is not something massive objects can experience, because reaching light speed would require infinite energy. Only massless entities like photons live in this strange regime, where our usual ideas of time and distance break down entirely. This transformation of time and space also reshapes the idea of simultaneity. In everyday experience, we assume that if two events happen at the same time for one observer, they happen at the same time for everyone. Relativity shows this assumption is false. Two observers moving relative to each other can disagree on whether events are simultaneous. There is no universal now shared across the cosmos. This loss of absolute simultaneity is essential to maintaining the speed limit and preventing contradictions in cause and effect. The protection of the cosmic speed limit is also deeply connected to energy. As an object accelerates, more and more energy is required for smaller and smaller increases in speed. This happens because part of the energy goes into altering the object's relationship with time and space. Energy is not just pushing the object forward. It is reshaping how the object exists within the universe. This is why no matter how powerful an engine becomes, it can never push a massive object beyond light speed. These ideas may seem abstract, but they have real-world consequences. Technologies such as GPS rely on precise timing. Satellites move fast relative to Earth and experience weaker gravity, both of which affect time. Engineers must account for relativistic time changes to keep navigation accurate. Without understanding how time and space change, modern technology would fail. The deeper meaning of all this is that time and space are not passive backgrounds where events happen. They are active participants in the laws of physics. They stretch, compress, and adjust themselves to preserve the fundamental structure of reality. The cosmic speed limit is not enforced by a wall or a force, but by the malleability of time and space themselves. This realization collapses the classical view of the universe. Instead of a rigid stage with moving actors, we have a dynamic system where motion reshapes the stage itself. Time and space bend, slow, and contract to maintain the consistency of the universe. They change so that the speed of light remains unbroken, causality remains intact, and reality remains logically possible. This is not just a strange feature of the universe. It is the very mechanism that keeps it from tearing itself apart. Energy, mass, and light are deeply connected through relativity. At first glance, energy, mass, and light seem like completely different things. Mass feels solid and tangible. Energy feels abstract, something that causes motion or heat. Light feels almost immaterial, something that illuminates but does not weigh anything. Classical physics treated these concepts as separate categories, each with its own rules. Relativity shattered this separation and revealed something far more unsettling. Energy, mass, and light are different expressions of the same underlying reality. The deepest symbol of this connection is the famous equation. Although it is often quoted casually, its meaning is profound. This equation says that mass itself is a form of energy. The term, the speed of light squared, is not there just to make the numbers large. It acts as a conversion factor, showing how tightly mass and energy are linked. A small amount of mass contains an enormous amount of energy because the speed of light is so large. This alone tells us that light speed is not just about motion. It is the key that locks mass and energy together. To understand why this matters, consider what happens when an object moves. As an object accelerates, it gains kinetic energy. In classical physics, this energy simply adds to its motion. In relativity, something more dramatic occurs. As energy increases, the object becomes harder to accelerate. Its resistance to motion increases as if its mass were growing. This is not because the object is physically collecting matter, but because energy itself contributes to inertia. Energy behaves like mass. As speed increases further, this effect becomes stronger. Near the speed of light, even a tiny increase in velocity requires an enormous amount of energy. This happens because the added energy is no longer going primarily into increasing speed. It is going into increasing the object's relativistic mass energy. The closer you get to light speed, the more energy piles into this resistance. At light speed, the energy required becomes infinite. This is why massive objects can never reach the speed of light. The limit is not mechanical, it is built into how energy and mass are connected. Light itself sits at the extreme end of this relationship. Photons have no rest mass, yet they carry energy and momentum. This seems paradoxical until relativity clarifies the situation. Mass is not the only source of gravity or momentum. Energy itself plays that role. Light can push objects, bend around massive bodies, and transfer momentum, all without having rest mass. This shows that energy is more fundamental than mass, and mass is simply one way energy can appear. This connection also explains why light always travels at the same speed. Because photons have no rest mass, they cannot exist at rest. They are not objects that can be slowed down or sped up in the usual sense. Their entire existence is tied to motion at light speed. Asking why light travels at the speed of light is like asking why a triangle has 3 sides. It is not a choice. It is a definition embedded in the structure of reality. The mass-energy relationship also reveals why nuclear reactions are so powerful. In nuclear fission and fusion, a tiny amount of mass is converted into energy. The mass difference before and after the reaction appears small, but when multiplied by, it produces enormous energy. This is not mass being destroyed, it is mass changing form. The universe allows this transformation because mass and energy are fundamentally the same thing. Relativity goes even further by showing that light defines the boundary between different forms of existence. Objects with mass must always move slower than light. Objects without mass must always move at light speed. There is no smooth crossing between these categories. This sharp division exists because of how energy behaves near light speed. If a massive object could reach light speed, it would require infinite energy, which cannot exist in a finite system. The universe uses this rule to maintain internal consistency. This deep connection also reshapes our understanding of gravity. In modern physics, gravity is not just caused by mass, but by energy and momentum as well. Light bends space, time, because it carries energy. A box filled with light weighs more than an empty box. These ideas feel strange because they contradict everyday experience, but experiments confirm them. Even light contributes to the curvature of space and time. The philosophical impact of this keynote is enormous. It means that matter is not a fundamental substance in the way we once imagined. Solid objects are frozen energy patterns, stabilized by the laws of physics. Light is energy in its purest moving form. Mass is energy locked into structure. The speed of light acts as the exchange rate between these forms, setting the scale at which transformations occur. This realization collapses the classical picture of the universe as a collection of solid things moving through empty space. Instead, we see a universe made of energy, structured by light speed, and expressed as mass when conditions allow. Nothing is truly static. Even the most solid object is energy held together by forces, vibrating at microscopic levels. Understanding the connection between energy, mass, and light reveals why the speed of light is untouchable. It is not merely a limit on speed. It is the boundary that defines what mass is, how energy behaves, and how reality organizes itself. Break this connection, and the entire structure of physics collapses. This is why relativity does not just describe the universe. It explains why the universe can exist in a stable, logical form at all. Richard Feynman revealed light as a process, not just a thing. When most people think about light, they imagine it as something simple and direct, a beam traveling from a source to a destination in a straight line. Even when they learn that light behaves both as a wave and as a particle, it still feels like a thing moving through space. Richard Feynman challenged this comfortable picture by revealing something far more unsettling. He showed that light is not best understood as a single object following a single path, but as a process that explores all possible paths at once. This idea does not just change how we see light. It changes how we understand reality itself. Feynman's insight came from quantum mechanics, where the behavior of particles cannot be explained by classical trajectories. Instead of asking, which path does light take, Feynman asked a deeper question: how does nature decide what happens? His answer was both elegant and shocking. Light does not choose one path. It behaves as if it takes every possible path between 2 points. Straight paths, curved paths, loops, and even wildly indirect routes all contribute. What we observe as the actual behavior of light emerges from the combined effect of these possibilities. This does not mean light physically travels along every path in a literal sense. Rather, each possible path contributes a probability amplitude. These amplitudes can reinforce each other or cancel out. Paths close to the shortest time route tend to add up coherently, strengthening the signal. Paths far from it tend to cancel each other out. The result is that light appears to travel along the path that takes the least time. What looks like a simple rule in classical optics is actually the outcome of an underlying quantum process. This perspective completely reframes the idea of speed. Light does not decide to move fast or slow. Instead, the speed of light emerges as a stable result of countless interfering possibilities. The cosmic speed limit is not enforced by a barrier or a command, but by the mathematics of probability and interference. The universe behaves like a vast computational system, where outcomes arise from the cancellation and reinforcement of possibilities. Feynman's view also explains why classical laws of optics work so well. Laws like reflection and refraction seem simple and deterministic, yet they arise from this deeper quantum chaos. When light reflects off a mirror or bends through glass, it is not obeying a rigid instruction. It is the sum of all possible quantum paths interacting with the environment. The classical path is simply the one that survives the interference process. This idea collapses the traditional separation between how and why in physics. Instead of asking why light follows a particular path, Feynman showed that the path is not fundamental. What is fundamental is the process that generates the path. Light's behavior is not imposed from outside. It emerges naturally from the rules of quantum mechanics. The philosophical implications are profound. If light behaves this way, then reality itself may operate through similar processes. Events do not unfold along single, predetermined lines. Instead, the universe explores possibilities, and what we observe is the result of constructive interference among them. This does not mean everything is random. On the contrary, it means that order emerges from underlying complexity. Feynman's approach also deepens our understanding of time. In the path-integral view, time is not just a ticking clock that events follow. It becomes part of the structure over which possibilities are summed. Light's apparent preference for the fastest path arises because paths near that time extremum align in phase. Time, speed, and probability become inseparable concepts. This framework also helps explain why the speed of light is so special. Since light has no rest mass, it exists entirely as a process of propagation. Its identity is tied to motion itself. Feynman's description shows that light is not a tiny bullet racing through space, but a pattern of probability unfolding across space-time. The constant speed of light reflects the stability of this pattern, not the endurance of an object. Perhaps the most mind-collapsing realization is that the universe does not know the rules in advance. There is no hidden intelligence selecting the fastest route. The appearance of optimization comes from interference, not intention. Nature does not calculate the shortest path consciously. The mathematics of quantum mechanics ensures that only certain outcomes survive. This makes the universe both simpler and stranger than we imagine. Feynman's view also blurs the line between particles and fields. Light is not merely a particle or a wave, but a process described by amplitudes evolving through space-time. This shift in thinking influenced modern physics deeply, from quantum electrodynamics to our understanding of fundamental interactions. It provided tools that allowed physicists to make some of the most accurate predictions ever tested. In the end, Feynman revealed that light is not a thing racing through space, but a story the universe tells itself through probabilities. The speed of light is not just a number. It is the rhythm of this story. By seeing light as a process, we begin to see reality not as a collection of solid objects, but as an unfolding pattern of interactions. This realization does not just stretch the mind, it forces it to collapse and rebuild in a completely new shape. If you liked this video, then like it, subscribe to the channel, and stay connected for knowledge.